Much easier than surface area. And then somewhere, I don't know if you guys have looked on in the packet, this lesson that you guys just did on the surface area, we're going to do the same lesson but with volume, and it's going to be so much easier. So volume is just much, much easier to do than surface area. Okay, in your foldable, I want to go ahead and do a volume example for the cylinder. We already have a volume example for the prism, but let's go ahead and do a volume example for the cylinder. So I'm going to use the same dimensions. And if you'll notice, a lot of the formulas for volume involve about the same thing. This is capital BH, this is capital BH, this is 1/3 capital BH, 1/3 capital BH. A lot of them kind of involve the same thing. The sphere is quite different, though. Hey, Austin, you want to turn around so maybe you can see a little bit better? I mean, you could just turn your whole desk. Okay, so looking at this formula here, I'm going to go ahead and I'm going to write down the capital BH. And I know we've replaced the capital B with a pi r squared. And why did we replace the capital B with a pi r squared?
Because that's the area.
Because that's how you find the area of a circle. And the base of the cylinder is a circle. So that's how we find area of a circle. So it would be pi r squared, so it would be pi times 7 squared. Okay, so it would be pi times 7 squared, because pi r squared is how you find the area of a circle, and that's the base of a cylinder. And then the height of the cylinder, what's the height of the cylinder? 12 is the height of the cylinder, so times 12. Okay, and let's work that out. Leaving it in terms of pi. Okay, 588, and that would be 588 pi. If I stick with the meters that I've been using, it would be meters cubed. So do you understand the difference between what volume is versus what surface area is? Surface area is like if you want to paint all the surfaces. So like if I had this composite figure here, and I wanted the surface area of it, I would only count the surfaces that I could actually paint. And I wouldn't be able to paint the top of this, and I wouldn't be able to paint the bottom of this. But what's volume? Yeah, it's like all the space inside. So if I wanted to know the volume of this shape, I'd have to find the volume of the entire pyramid, because I could fill all of that up with air, let's say. And I'd find the volume of the entire cube, because I could fill all of that up with air. Whereas surface area, you don't have all the surfaces, because you don't have this surface and you don't have that surface. But if it's volume, if you have volume, you have both shapes, and you'd fill both of them up completely with air. Okay, in our packet, this is just basically just talking about what prisms and cylinders are, and we already know. So let's just move on and do a few examples. Okay, let's start with example 1. And we are just finding volume. What shape do we have for number 1? What is number 1?
A cube.
It's not quite a cube. It's a rectangular prism. So I'm going to come to the rectangular prism. I'm going to come to the top section. And our formula for volume is capital BH. So, capital BH. And I know that capital B stands for what again? The area of the base. Let's just call the bottom the base. What would the area of that base be?
36.
36. And then how tall does the prism stand? 4. And 36 times 4 makes? 144, and it would be inches cubed. Volume is always in cubic units, and it's like you're filling it with air, you're filling it with water, you're filling the whole inside of it. Okay, number 2. What shape do we have going on here? A triangular prism. The fact that it is a prism, I'm going to use the same formula that I used the last time, capital BH. Capital B stands for the area of the base. What shape is the base? A triangle. So this time I need to know the area of the triangle. So how do we find area of a triangle? 1/2 base times height, or base times height divided by 2. What's the base and the height of the triangle?
7 and 6.
7 and 6. Beautiful. Wherever that right angle is, the base and the height, they're always attached to it. And what do you get if you work that out? 21. So that's capital B. And then how tall does the prism stand?
16.
16. And 21 times 16 make?
336.
336.
Meters
And
cubed.
beautiful. Meters cubed. Choo, 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 choo. Okay. And then example 3. What shape is that?
That's a cylinder.
It's a cylinder, so I'm going to go to the cylinder, and the volume formula is capital BH. And then I know capital B stands for area of the base. And what shape is my base? And how do you find area of a circle? Pi r squared. So pi times radius squared. And what's the radius of it? 5. And then how tall does it stand? 10. Just give it to me in terms of pi.
250 pi.
Good. 250 pi. And then that would be feet cubed. And you can always give me the decimal. It's just easier, in my opinion, to just leave it in terms of pi. But I'm happy with anything. Those 3 seem easy? Okay, so I think you're going to find that volume is much easier than surface area in general. Of course, we do have more challenging problems than these right here. But basically, that's it. And we have already done these problems. We just did them with surface area. So some of this stuff, we've already calculated some things. You just may not remember unless you looked back. But at the time I was doing this, first, let's just talk about the shape. What shape is this? Trapezoidal prism. Because it's a prism, I am going to use the prism volume formula, which is capital BH. Again, capital B stands for area of the base. And what shape is the base?
A square.
Trapezoid. The trapezoids are the bases. All the sides are rectangles, which is what makes it a prism. Okay, so I need to find the area of this trapezoid. So I do need to know its height. And how tall is it? 8. I do need to know its bases so I can add them up. 10 and 14. That base is 10. We know that base is 14. And you always add the bases. And you divide by 2. And can you tell me what that is? 96. Good. So that's the area of the base. And then I need to know how tall the prism stands. So if you set it up on its trapezoidal base,
14.
it would stand 14. Okay, and how about 96 times 14?
1,044.
Good. Inches cubed. This one was pretty easy because to find the area of the trapezoid, I just needed to know the height, which I already knew. I needed to know the bases, which I already knew. But when we did this problem before, I'm going to flip back for a second. Oh, no, I don't. That was a different packet. Oh, we did this one in. I don't know if I still have it. When we did this problem before, we were doing it with surface area, and it was much harder when we did it with, that's not it either. It was harder when we did it with surface area. That's not, oh, there you are. Because when we did it with the surface area, or I'm sorry, when we did the surface area, we had to know the perimeter, and we had to know what this was, and we had to do Pythagorean theorem, and we had to do a whole lot more with it. It was a much more difficult problem when we did it with surface area. Okay, number 5. What is that?
That's a pentagonal prism. Hexagonal prism.
A hexagonal prism or a hexagonal prism. Okay, so the fact that it is a prism, I'm going to use the prism formula, capital BH. Capital B stands for area of the base. What shape is my base?
Hexagon.
A hexagon. How do I find area of this hexagon right here? Good. 1/2 AP. Lots of talking. So I'm going to draw this in. That's the apothem right there. I'm going to go ahead and make a triangle out of it. And we keep working with this same hexagon, so most of you already know. What is this angle right here? 30. If I didn't know that, I would take 360, divide by how many sides a hexagon has, which is 6. That makes 60 degrees. So this is always half that, because 60 degrees is this central angle right here, so the 30 is half that. Okay, and then do you guys know what this piece is right here? A 5, because I know it's 10 all the way across, so that's a 5. and that's a 90, and that's a 60. Okay, so across from the 30, what do you label with? X. Across from the 60, x squared root of 3. That's all I really care about because that's the apothem. So if x is 5, what's the apothem? 5 square root of 3. Okay, so now I can find my area. 1/2 the apothem, which is 5 square root of 3, times the perimeter. And if this is 10, that's 10, that's 10, that's 10, that's 10, that's 10, that's 10. What's your perimeter? 60? Okay, give me that answer in terms of pi. I'm not, sorry, in terms of the square root of 3. 150 square root of 3, and that's the area of the hexagon. That's the area of the base. So 150 square root of 3. And then how tall does that prism stand? 4. Okay, what do you get if you take 150 times 4?
You get 600.
So the answer would be 600 square root of 3. And of course, I could always put that in the calculator and get a decimal. Let's just go ahead and do that. If we put 600 square root of 3 in the calculator, what do you guys get to the nearest tenth?
1,039 point dose.
Good. 1,039 point dose inches cubed. Well, I was just repeating Andrew because he's cool, you know. All right. Do you get it? Easy peasy? All right. So I'm just going to let you guys work so you can try to get this done. Let's see here. Last time I think we crossed off number 7. But these are so easy. Do you see number 4? Do you see him? You had already done this problem before, and this was the problem that was on that quiz yesterday. So this problem you had already seen before. Here it is again, but today it's different because it's going to be volume. Okay, let's just go ahead and be consistent. Last time we saw this page, we crossed off number 7, so we'll just cross off number 7. And then if you would, on a separate piece of paper, I want the same thing. I want formula, plug in the numbers, answer.
I thought we crossed off 6 and 9.
We did on the next one. The next lesson, we crossed off the 6 and the 9.
I thought we crossed off 1 and 9.
I can show you. Before, when we were doing lateral area and surface area, see how we crossed off number 7? No. We crossed off 6 and 9 on the next lesson.
I see 1, 2, 3, 4, 5, 6, 7, 8, 9.
But this shouldn't be too difficult, and you guys have like 14, 15 minutes right now. But formula, plug in numbers, answer. But please do it on a separate piece of paper. And it'll be fun, I promise. Oh no, I'm